Hi, I'm Spencer Krause. I've been building robots for over 20 years. In that time, I've seen a lot of interesting things, and I've heard a lot of interesting stories. Collaborative with Spencer Krause is a place where my peers and I can relax, have a drink, and talk about some of the crazier things we've seen at work and some of the experiences we've had that have gotten us to where we are today. Subscribe today to join the collaboration. Welcome to the Collaborative Podcast. I'm your host, Spencer Krause. Our guest today is Pras Velagapudi. Pras is the Chief Technology Officer at Agility Robotics. Pras, welcome to the pod.
Thanks, and thanks for having me, Spencer. And it's great to be here. And obviously, you and I have known each other for, over like 10 years now, working in robotics, right?
Yeah, it feels like it. I mean, we met at Carnegie Mellon, worked together in a few projects. Good to have you in the studio after all those years.
Yeah, no, it's great to be here, and thanks for having me.
Thanks for coming in.
I've been in robotics for, I think, a total of a little over 20 years now.
Awesome.
About half in academia and half in industry, which is really kind of fun. Like, I actually really enjoy both kind of halves of the robotics world. And when we first met, that was over at Platypus, which was the company that I co-founded, a spin-off of the Carnegie Mellon Robotics Institute to commercialize robotic boats. And you were helping me make them.
Happy to do it.
Yeah, and still around, still making boats, by the way.
Sweet.
So thank you for your efforts in helping us.
Hey, my pleasure. Always happy to help with a cool project.
Yeah. So yeah, it's been kind of a wild ride. I spent a bunch of time at the Robotics Institute, working on a ton of different projects. Really a ton of different experiences. And then I switched over to industry, and I've been working on a lot of different types of industrial robots, and most recently humanoid industrial robots, which is very exciting over at Agility Robotics.
Awesome. So how'd you get into that? Like, what made you decide to kind of take the plunge? Did they recruit you? Were you kind of thinking about it anyway, and you were looking at a bunch of them?
So I was fortunate enough in that my previous role at Berkshire Grey, we were very successful. You know, we managed to take the company public and deploy robots at customer sites. And actually, two of the co-founders of Agility Robotics are actually CMU alumni and overlapped with me when I was at Carnegie Mellon as well. Awesome. So we're kind of old friends. And if you look at the really, really old Agility Robotics video, like one of the first ones where it's still...
Like a Cassie video?
Even earlier than Cassie.
Oh, wow.
This is when Jonathan Hurst, one of the co-founders, was still working on one leg, just one leg. And so he was building this one leg, and I helped him with the software for that one leg. And so I'm in the background of the video, sitting over in the corner, like at a computer while he's like showing off the leg. And so for me, it was kind of like coming full circle in a big way where, you know, I had gone through, you know, learning all these different systems and working on all these different robots. And really, we kind of connected. And he had been working on, you know, legged locomotion and building a humanoid this entire time. And I'd gone and done all these other things. And it was kind of like, hey, do you want to kind of come back to this really exciting, like crazy, ambitious type of robot? And I was like, yeah, that sounds really cool. I'd love to help with that again. And so it was kind of like a big full circle moment for me to get back into kind of, in some sense, one of the first robotics projects I ever did when I came to Carnegie Mellon.
That's awesome.
Yeah.
So you knew him from all those years ago, and then you just reached back out like a decade or more later.
Yeah, we kind of reconnected. I mean, of course, we've been kind of keeping in touch over the years, but yeah, we reconnected. I'd gone out to sort of visit him and just, you know, catch up and so forth. And when I saw, you know, the progress and what he was, you know, what the company was working on, it was really compelling, and it seemed like a good time to get back into it.
That's awesome. It's certainly cool technology, and I mean, being the CTO of something like that is an incredible opportunity.
Yeah, no, I'm very lucky. I mean, knowing the founders and getting brought into the team at that for this type of role for me was a great opportunity, and I really kind of lucked out in that they were very welcoming in bringing me in, and I've been really excited to work with the team there and basically like take us through this next phase of like, we have a humanoid robot, now we're like getting it out in the world. And I get to work with a really great team of people in general, like some really talented engineers, some really talented folks in our leadership team, So it's actually been quite a like learning and rewarding like co-working experience in general.
That's great. Yeah, no, it seems like you guys have a solid team over there.
Mm-hmm.
So I guess, what are some of the more interesting things you've done technologically since you came over to Agility? And then also, I want to get into like some of the business cases. I got a lot of stuff I want to ask you, but we'll start with the tech because we're both super nerds over here.
Yeah, so the tech is really cool. So, I mean, it's really it's basically every problem in robotics all in one platform, right? You're dealing with moving around a humanoid platform. It's dynamically stable. It's got arms, it's got legs, it has to do perception. And so you're sensitive to mass, you're really sensitive to physics dynamics. And at the same time, you have all of the same manipulation controls and perception problems of like every other platform out there. So you're really like taking on the biggest robotics challenge in some sense. I mean, obviously other robotics folks will argue that they also have compelling challenges, and they're not wrong. But there's a lot of them in one package here. But the
fact that gravity is fighting against you.
Yeah, you're dynamically stable. Like you have to constantly control yourself to balance. But with all of those challenges come a lot of capability, right? Digit being indoors versus outdoors, you know, and being able to like navigate and move around like small objects versus large objects. For us, it's all kind of part of the same spectrum. You don't write like two different control stacks for one and then the other. You just have one software system and one hardware platform that like spans and bridges this whole range of stuff. And that's really cool. It's really cool when, you know, one of the things that I do is I work with our innovation team doing research and development alongside Jonathan. And one of the really cool things is that we're doing all these pieces of work for customers where we're, you know, in a warehouse and we're moving bins and totes. And I can take that same platform, right, and load up a slightly upgraded version of code, you know, from our innovation team. And that same platform can now pick up bags of chips or clothing or like walk outside on the curb or in the street, you know. That's really cool to me. The fact that, you know, it's not a single purpose platform that's built into one particular use case and is just sort of like living there.
Yeah.
It's this platform where every time you add a new capability or every time you expand its functionality, that works across the board in lots of different potential domains.
So really you're trying to unlock more capability with software upgrades. I mean, the hardware, it sounds like, is kind of like you can do the same stuff you'll be able to do with the next generation. So really like the cutting edge cape unlock is like, you know, how do we get better software into this thing?
Well, it's not quite as simple as that. So there actually is quite a lot that goes into the hardware. So we have like custom actuator technology. We have a lot of engineering that goes into mass optimization and design of the platform to make it work. But in some sense, we design a platform that's got extensive capabilities across the board, right? The hardware is really capable. And so we can unlock that with our software. And so if you build a capable hardware layer, then now software can just increasingly unlock different things because it can do all of that stuff.
Sure. But I mean, I guess where I was going with that, and maybe this is true of every robot, is, you know, the hardware layer, like, I mean, you have to come up with another version to upgrade that. The software layer, you can continually upgrade. I mean, it's universal in robotics. I was kind of just making
I guess, you know, to make it like an analogy, right? It doesn't matter what type of software you put on a Roomba. It's never going to fold your clothes, right?
Right, yeah, 100%.
And so we have a platform that could fold your clothes, right? It has arms, it has grippers,
but
it has perception.
Can Digit do a cartwheel?
Can Digit do a cartwheel? That's a good question. So no, I think
that would be like the folding your clothes to the Roomba.
Yeah, exactly. So Digit will not do a cartwheel in its current form. Kinematically, no go, right? Yeah. And we would need a different set of hardware to do cartwheels, right?
Yeah, makes sense. But there's no business case for that, so why spend the resources?
That's right. Yeah, there's no business case for that. And there's quite a lot of things that you can do without doing cartwheels.
100%. Cool. All right, no, that makes a lot of sense. But you've attacked like kind of a general set of like what you see to be humanoid business cases.
Yeah, so we're starting with these industrial automation use cases. And the reason for that is twofold. One is economically they make sense because we can make the robot do something that's valuable right now. It's not like, you know, in some future we're going to help you out in, you know, 20 years from now. It's like, no, in a warehouse, if you do these things, like this actually will save me time and effort, right? So that's the one thing, is there's a real market like today, not in a
What
decade.
are some of the tasks that you're giving to Digit that, I guess would otherwise be given to some other piece of equipment in an industrial situation?
Yeah, so sometimes there's other pieces of equipment. Sometimes it is people, but the people that aren't doing this full time. It's essentially kind of the moving around of large bins, large totes, large pieces of what's called machine tending, which is like pieces of equipment that might need to be assembled or loaded into some sort of manufacturing process. That
So
type
like
of
putting a piece of metal into like a CNC mill, for instance.
yeah, like
or
loading,
pulling out a part?
unloading. That's exactly it. And so that type of stuff is really, I mean, it's menial for one thing. It's heavy and awkward and not really the greatest thing to be doing for 8 to 10 hours a day per shift, right? And it's also stuff that, has a high degree of repeatability. Like a facility that's doing that might be doing it in a lot of places or at a lot of different facilities.
Yeah, that makes a lot of sense. So you're saying that once you nail the code to do that, you can take that and replicate it to other locations for that client.
Yeah, and that just really kind of makes sense from a business perspective. While we want a robot to be able to have a lot of capability, and it does, because we are doing this for multiple customers that don't all have exactly the same use cases, we don't necessarily want to do this work and then have to like make 12,000 little variants of it for every single, possible use case. That's like, oh, well, this one's a tote and this one's a slightly different box and this one's like hanging on the wall and not. We want to kind of like start with something that's replicable that we can deploy a lot of and then build out the capabilities to do more and more. And so we can do all 12,000 of those things,
That makes sense.
not need to do them all right up front, right?
But your software team is probably looking for like, and your end effector design, and different things are probably looking for like, what's that, thing that's going to make us the most amount of money with the least amount of work first. Then what's the second most amount of money with the second least amount of work?
Yeah, right. It's a very straightforward business
That's the ratio.
optimization.
Yeah,
right,
exactly.
You're trying to, increase your entitlement and try and do the
Money
most
over work.
You try and do the most you can up front with like the biggest use cases and then keep filling out that tail so you do more and more. But the advantage being that we have a platform that can do more and more.
Yeah. Where if somebody takes like, I don't know, when I was at FormLogic as director of advanced projects, or that was my title. Yeah, it was a weird title, but it was a director of advanced projects. We used George Fisher System 3Rs to load and unload our CNC machines, and those were great for that purpose. And I'm sure a FANUC, whatever, would do the same thing, and you could do that with the Yaskawa. But you're saying then yours can go and clean the floors as well.
Yeah, or load a different machine, down the aisle a little bit, or you've got, 20 digits and they're doing this with different machines. And if one breaks down, you could move the other one over here and it's not a different piece of hardware with different tooling.
So your changeover is easier. Okay, that makes sense.
Yeah, so you're really like, in any deployment of robots, there's some amount of cost to like integrate the robots into your warehouse, like connect it to the messaging, train your people on how to use it, have the spare parts available. It's really great if you could do that once with one type of robot and then use it in a lot of different places. So all that like training overhead and network connections and connecting it up to your management system, you do that once. And now it's like, okay, well, yeah, if I want to have it work on this machine and then this other machine and then this other maybe moving, storing totes or something like that, I'll just take the same platform and I just stamp it or slot it into each of those places.
Yeah, and I mean, I guess I could see that too with unit management being advantageous. If you have to have hot spares of 10 different types of robots versus one type of robot, I mean, your logistics of hot spare units, I mean, gets a lot simpler for sure.
Yeah, exactly. I mean, it's something that is one of the reasons that customers kind of come to us right now, is they're looking at the vision of, hey, this is a platform where we may not need all of these different types of automation, and every single time it's like its own area in the maintenance cage,
Yeah.
Collaborative with Spencer Krause is sponsored by SKA Robotics. If you're in the market for elite field robotics expertise, please consider hiring SKA Robotics. They sponsor this podcast and solve some of the toughest engineering problems in the world. SKA Robotics can be found at skarobotics.com.
What are some of the other tasks you're looking at Digit for besides machine tending?
So machine tending is actually a little further out. A lot of what we're doing right now is bulk manipulation.
I guess
moving
I've
around.
seen videos of that, right? It's like pick up this box,
Yeah,
up this garbage.
if you go to
you
our
saying pick up this garbage,
clean up this mess. Yeah,
clean up this mess.
Clean up this mess is actually also like a little bit further out, but it's one of the ones that we're really interested in. Longer term. A lot of what we do is bulk manipulation. I mean, the robot's really good at moving around heavy loads, and so a lot of our initial use cases are, carry this metal bin of parts from point A to point B, carry bins of clothing. Actually, our GXO deployment that we have right now is carrying inventory bins of clothing and feeding them into a conveyor system. So that type of task still happens a lot in warehouses and is often not easy to automate because of the things that it's connecting. So you might have something like a conveyor on one side and something like an AMR, an autonomous mobile robot, on the other side.
Oh, interesting.
And they just sort of like are sitting next to each other, but there's no way to go from one to the other, right? There's no thing that goes from the shelf to the AMR or the AMR to the conveyor. And so a person's often stuck, like just filling this gap and going back and forth, right? And so that's awkward, obviously, and it's not a super fun thing to do. And so this is what we can automate. We call it kind of like islands of automation. You have your entire giant, awesome automation system here and your other entire giant automation system here. And then in the middle, you have these two islands. Yeah. And then you're like, oh, we're connecting it with like a person.
Yep. Yeah, that makes a lot of sense. You can pop a digit there and then, now you've got all automation.
Exactly. Now you've connected the whole thing, and now your islands are connected.
And I've definitely toured facilities with people in those kind of crappy jobs where they're being screamed at by a computer and there's beeping and direction and they have to do an 8 to 10 hour shift of just staring at a screen and moving things with their hands, and it's got to wear on your soul, I would think.
Yeah, and in a lot of cases, these are crew cycle jobs in a lot of cases, which means that a person's rotating through multiple things that they could be doing, right? And one of their things might be
to maintain their sanity, I'm sure.
Well, sometimes I think in a lot of cases it's because of just the load between multiple jobs is such that a person kind of does several jobs to kind of depending on the demand. Sometimes in the morning they're doing something, in the afternoon they're doing something else. But what we can kind of do is automate away the most bulk moving kind of repetitive part of this and then leave the other pieces. So it's like, okay, you can go, continue to do other stuff, like maybe check on inventory, problem solve things, do value add stuff, like maybe, you like putting, a nice wrapper on a gift bag or something like that. Like these operations that are a little bit less strenuous and that are still need
harder
to be
harder
to automate, but also potentially like more require a little bit more cognitive sort of like thinking about what needs to be done or problem solving or things like that.
Which more mentally stimulating for sure.
It's in warehouses where I've, sort of run through parts of a shift. It's certainly the more interesting stuff for me when I'm there. Of course, I've, not had to work many hours in a warehouse, but, going in and doing the task for a little bit of time, you get a feel for, which things people want. And you also can talk to the people there and they have their own preferences.
Yeah. That makes sense.
Yeah.
I'm sure some people just want to turn their brain off and do the most mundane thing possible. I'd imagine other people want as much intellectual stimulation as they can get. So. Well,
it's at the end of the day, regardless, it's great if you don't have to move 50 pounds of stuff back and forth, right?
Sure. Yeah, there's plenty of robots that alleviate that.
Yeah, and there's plenty of other things to do in the facilities, right? Yeah. If we're taking over this one area, all that means is that's increasing the throughput of the facility by a certain amount, and they just end up using that spare capacity to just increase the overall throughput of the facilities pretty much.
Yeah, it makes a lot of sense. When you have more capacity, but you've got demand, you figure out
people are always pushing for trying to match the demand. E-commerce and third-party logistics sectors are constantly growing and trying to figure out how to get their existing facilities to be able to run more efficiently and be able to handle more.
Yeah, that makes a lot of sense. So what was the second thing that we were going to talk about?
Yeah, so the second piece of this, right, and one of the reasons that we started in industrial automation is that in addition to the economic side of things, there's also the safety side of things. We have a dynamically stable humanoid robot. That means that it's constantly doing control actions to stay stable.
Sure.
That's something that's never really been certified or never really been explored from a safety standards perspective. It's simply too new, right? And so the standards that exist in industry are a lot more formalized and a lot more mature than they are in some other industries, especially in things like home and retail. There simply have been fewer robots deployed in those areas. There's less clear standards about it, and there's less historical stuff to base the standards around what would be sufficient to make a robot safe. So we do have the advantage of in industry, we have at least this framework to build on. We have things like RA 1508. We have standards bodies such as UL and A3 that are, at least they've for a long time thought about these problems, and maybe they haven't done dynamic stability, but they've been doing other types of robotics applications, and they've been thinking about it really hard, and they have organizations and standards committees that have a pretty good structure for how to figure out how to make something sufficiently safe.
Oh, that's interesting. So the existing standards and automation aren't necessarily exclusive or exclusionary of dynamically stable platforms.
No, it's that they mostly just don't specifically call out what you would need, but they describe it in terms of what any robot should need in order to be safe in broad classifications. And so now a lot of the work that we do at Agility has been into expanding those standards to write clearer guidance or develop clearer guidance around what that means for dynamically stable robots. And we're not alone in that. We're working with other industry players, but it's a main focus for us. But one of the reasons to start an industry is because that framework is there. We have a better sort of idea of what it would take, and we're working with people that are more familiar with automation in their facilities. They've already seen an AMR. They already have a conveyor system. They already have maybe an automated storage or retrieval system, which is big, like steel cubes that have like tons of robots running around them, or
like an
cranes.
Auto store.
Yeah, like an auto store or a Dematic multi-shuttle or things like that. But they're familiar with that. They know how to run them. They know how to train for them. They know how to maintain them. And they know how to safely interact with them. And so that like helps out a lot when we're introducing a new type of automation. Whereas if you take a completely greenfield application, like, you're saying, oh, we're going to introduce a robot and it's going to, take pizzas out of a pizza oven. And it's like, okay, well, what do we need to do for that?
There's no standards for that.
I mean, there are some standards, but there's way less prior art. It's not like there's a bunch of restaurant loading robots to look at.
There's like one or two.
Yeah, well, there's like the Bear Robotics platform's a good example that like delivers trays, and I've seen that's actually been taking off in quite a few restaurants. But again, like it's simpler, and it's also like there's fewer of them to look at, right? You have a few platforms and they're kind of more simplistic or constrained.
Yeah, for sure. Yeah, I mean, are there like a bunch of different pizza robots? Like, I feel like that doesn't. Who's making a standard around pizza robots?
There are a few companies who have attempted to varying degrees to automate making pizza.
Sure, and I've seen it as a vending machine. So I've seen it like where like there's like this was from 10 years ago. There was like a drippy thing from the top that was just spitting tomato sauce down, and a spinning pizza, and then an oven turns on, and then your pizza comes out the side.
Yeah, so there is food automation, right?
Yeah.
But like a lot of the food automation is not a standalone mobile robot. It's like more of an appliance that puts together different steps and is kind of like just constrained. Like you just put walls around it and you don't like try and get into it, right?
Fair enough. I mean, I interviewed the former CTO of Miso Robotics, and they were using Yaskawa arms. I think they were Yaskawa to, deep fry stuff. So that was
so that's actually Miso Robotics, right, made huge inroads into this industry, right, with Flippy and the other technologies that they deployed, right? They do guarding, right? They just do guarding around their system. And they may have some collaborative. I don't know if they have any collaborative things as well. But they're largely building on what the existing industrial arms sector has for safety, right? And so that's the thing, is that like industrial arms safety is like a little bit more mature. You can rely on it a little bit more. Mobile robots, again, is also there, but this confluence of all the sectors coming together of now we have a mobile robot with arms that has to manipulate stuff. So you can't just like not touch anything.
So if you've got to take the fries away from Flippy and put them into the Bear Robotics platform, you need a digit, is what you're saying.
Well, all I'm saying is that we would like a digit to be able to do that. Like, maybe there'll be some other way to do it, but the idea is that you won't have to think about that because a digit will just be able to.
Right. That's awesome. Cool. So what are some of the robotics companies that you're particularly interested in or you're watching right now?
Oh, that's an interesting question.
Bit of a curveball, I know, but just to mix it up a little bit.
That's a good question. I mean, obviously there's folks in our sector, but that's neither here nor there.
Sure, we could talk about all sorts of humanoid companies.
Yeah, so I mean, it's been an interesting time because when I originally was joining up with Agility, there weren't a lot of folks in the sector, and really it's kind of exploded because of interest, both from an investment standpoint and also from a public standpoint. It really kind of caught the public's eye, and also from an AI standpoint, we kind of hit this weird explosion of AI technology that translated very well into capabilities for human-like platforms.
Yeah, it's an enabler for sure.
Yeah, in particular for humanoids. We basically basically discovered a class of AI algorithms that's very, very good at capturing information from data sets of human knowledge, right? And we have a lot of data sets of human knowledge around humans doing things, but we don't have necessarily a lot of data sets around other types of things doing things. Like we don't have a huge data set of how, like a mouse might navigate the world.
Sure.
But we have all this YouTube video of people doing stuff and all of these books about people doing stuff. And so it translates really well to a humanoid robot doing stuff.
But that's interesting. Are you actually able to train it from like watching YouTube videos of people doing tasks? Is that
parts of it? Yeah. Okay. So certainly like things like the task generation and some of the motion generation, you can seed it with information from YouTube videos, from motion capture data sets, and of course from robotic execution data as well. You can kind of dump all of them in. That's the brilliant part about a lot of these modern AI frameworks, is that they can take this type of multimodal data where they could just ingest a lot of different things, a description of what you're doing and a video of someone doing it and labeling about that video and maybe a robot trajectory of a robot doing it.
Do you have to do skeletal mapping, like overlay on the video, or?
Well, that's the thing, is it depends on the strategy you're doing, right? Sure. You could, but in a lot of cases you don't really have to.
Interesting.
Yeah, especially if you've pre-trained the model on other video data, it kind of builds up an internal structure.
So
do you know
what it's watching for? I mean, this is me not being an AI expert at all, but do you know what it's watching for in the video, or is it just ingesting them and spitting out useful, actionable trajectories?
So explainability is a bit of a challenge. There's some people working on trying to unravel exactly what that means, but it is a little bit opaque in terms of structurally exactly what's going on under the hood. And that's a challenge, right? Because you have a system where it generally produces this reasonable output, but you're never quite 100% sure that it's going to produce this reasonable output.
Do you what kind of confidence do you typically get like a reasonable output with? Like maybe like 70%?
I mean, it depends. It depends on the type of prompt, and it depends on the models. The models have been advancing quite a bit, and we work with
2024 Q4.
Yeah, exactly. Well, I assume that if you're watching this in the
yeah.
future, it's even more true than it is now.
Yeah, most likely.
That's a huge
Unless
benefit.
we had a nuclear war or something horrible happened.
Well, there's an interesting aside about that, which is as AI is used to generate more and more content, the problem is that a lot of these data sets get polluted with AI generated content, which is then leaking into the training data. And so then you actually kind of dilute down the provenance of the information, essentially, and that potentially could be a really big problem.
Feedback loop that could ring out of control effectively.
Yeah, some people have hypothesized that this will become a problem where basically the data sets that are being used
more and more bizarre.
The knowledge data sets
into itself.
Yeah, they'll start to feed back on inaccurately generated data and then train on that. And
hallucinations get weirder and weirder, and you end up with something that doesn't make any sense as your output behavior.
Maybe that's kind of a hypothesis that some folks have right now. So we'll see what happens.
That's interesting. I've never heard that before, but I was just kind of riffing on what you said. Cool.
Yeah. So it's a real concern.
No, that's interesting. I mean, I could see it being like, it makes sense. Artificial data was always a problem. I think I first learned about that when I was taking Howie Choset's class way back in the day, and there was the sumo robot challenge. And I remember we thought we had the coolest strategy. I think we had a wedge, and we geared our robot really low, and we thought no one else would think to counter this. So to make it super secret, we locked ourselves in the machine shop in the CMU Robotics Club. We wouldn't let anyone else in. And we made our own sumo robot board, and we got our thing programmed and working, and we went to the real thing, and the black was a slightly different shade than ours, so our robot wasn't thresholding it right, and it backed itself off and disqualified itself.
I've been there. When I was in, I think it was high school, I competed in bot ball. Same deal. Robot backed itself, fell off of the table, destroyed itself.
You could fix that in like 5 minutes if you just know what the course is going to look like.
Yeah.
But you don't want people seeing your strategy. So.
Well, yeah. But actually, that's an interesting thing, is that like now I feel like we're starting to get into these generalized models that are less susceptible to this. They generalize really well. Like you're not needing to do all of this detail of tuning them exactly precisely the way that we've done for years. And that's really exciting to me. I love this idea of just like we could take a model and stick it on the robot and do something like clean up this mess, where we're just like, let's just do this. That was very cool. And we can do other things like that where we'll just try stuff. That's crazy. To me, that was something that 10 years ago I wouldn't have dreamed I'd just be able to sort of go up to my robot and be like, let me just try this voice command and it might just work. So I don't know. That's really exciting.
That's pretty cool. So what are some of the other like long tail use cases? Like, I mean, for me, when I think of humanoids, like I feel like, and maybe this is me just being naive to the field, but I feel like space exploration comes to mind as like a thing that makes sense, because if you can only fit like one robot in your cargo hold, may as well be a general purpose robot, because you're going to have to do a lot of different things on Mars and you don't know what they're going to be yet. But I don't know, like what are some of the other like things you're seeing for it that, are kind of out there? Just to make it a little weird for us.
Well, I mean, there's a lot of the normal things in some sense, like
moving boxes.
We've talked about we've talked about like the sort of standard industrial and manufacturing kind of logistics and manufacturing use cases. Beyond that, though, I mean, retail and home use, like they're real use cases. If you can build the platform and you get it to the point where it is reliable and it's able to do these tasks,
cost effective, I would think for home use is a barrier to overcome.
Yeah, definitely. And that's another thing, is that, economies of scale, right? An industry can support a slightly more expensive robot if it's being made for, running 3 shifts of operation.
Right.
If it's going to work for like 2 or 3 hours at your home, like it needs to be a lot less expensive because, the value proposition is different.
I mean, it's hard to make a differential drive robot cost effective for home use.
Yeah, just ask iRobot, right?
Right.
But it's a long.
Again, how many people bought the Astro for $1,500 from Amazon?
I mean, people have a long and storied history of struggling to get robots into the home, and so for us, that's more of a we're gonna build out the capabilities, and if we can get it to the point where it makes sense to be in homes, then so be it. But there's a lot of other stuff for us to do, and just the whole world outdoors. We have a legged robot. That's one of the key advantages. Is we could be on docks. We could be loading and unloading out of garage doors. We could,
awesome.
Go in and out of trucks, and we have some challenges in terms of actually deploying that way right now. But the core technology is there. Like Digit has walked into and out of the back of a truck dock and into a box truck, and it's walked on grass. We've taken it on trails. We've taken it on curbs, all of that. We know the robot can do it. It's just a matter of packaging it up and getting the reliability up and presenting, a full solution that someone can use.
Yeah, that makes sense. There's a lot of challenges to operating outdoors, I think, for any machine.
Yeah. Well, sealing the robot, that's a big one.
Right. Yeah, 100%. Yeah, ingress protection's a real challenge.
Mm-hmm.
Yeah. So, I guess this is probably a good stopping point. I feel like we've covered a lot of ground. Is there anything you want to plug as we near the end of the app?
Oh, geez. I probably should have prepared for that. I don't have a book coming out or anything.
Yeah, fair enough. Buy a Digit for your home, factory, school,
Buy a digit for your factory. Please don't buy a digit for your home, though. We don't want to do that just yet. It's not going to be good for your home. It's going to be very expensive right now for what you can do. But for your factory, for your warehouse, definitely reach out. If you're interested in seeing videos of Digit doing cool stuff, we have a very active YouTube channel where we post, videos of Digit doing cool things, of working at customer sites, and interviews with people like myself and Jonathan who work at Agility about how the robot works and
Awesome.
What we're doing.
Great. Well, hey, Pras, thanks for coming on. I really appreciate it.
Yeah, man, it's good to see you again, and thanks for having me on here.
You too, brother. Always a pleasure. Thanks for coming.
Thanks.
Thanks for joining us today. If you've made it this far, chances are you'll like other episodes too. Collaborative with Spencer Krause is available on YouTube, Spotify, Apple Podcasts, Google Podcasts, Pocket Casts, and Radio Public. Subscribe today to get notified when the latest episodes release and support the channel. Collaborative with Spencer Krause is sponsored by SKA Robotics. If you're in the market for elite field robotics expertise, please consider hiring SKA Robotics. They sponsor this podcast and solve some of the toughest engineering problems in the world. SKA Robotics can be found at skarobotics.com. Thanks again, and see you on the next one.